this one. Let us start the first question. So the first question is, what is the SI unit of electric charge? What is the SI unit of electric charge? What is meant by charge? Charge is nothing but which experiences electrical forces. Which experiences electrical forces. That is nothing but charge. For example, if we have a positive charge, if we have the negative charge. So unlike charges are repel. So sorry, unlike charges are attract. Okay, so like charges are repel. Like charges are repel. That means this attractive force or repulsive force are experienced by these two charges. Okay, experienced by these two charges. That means which experiences that electrical forces, attractive or repulsive forces. That is nothing but electrical charge, and units denoted with letter Q, and units are coulombs. Units are coulombs. Okay, coulombs has given the two important laws on this chart, so that's why the units are becomes coulombs. Coming to the next one, which law will give the magnitude of force between the two static charges? Which law will give the magnitude of force between the two static charges? Here, Coulomb's given two important laws. Coulomb's given two important laws. Coming to the first law. Okay, what is this first law? This first law will give the nature of force exists. Nature of force exists between the two static charges. Here he has given like charges repel, unlike charges attract. Unlike charges attract. That is the first law. That means he will give the nature of force, which type of force, repulsive force or attractive force. And coming to the second law has given, if the two charges are displaced with a certain distance d, then there is a force will be exist between that. That force is proportional to the product of two charges by distance square. If you remove the proportionality constant, you are getting k into q1 q2 by d square. Okay, here k is equal to 1 by 4 pi epsilon, or the value is nothing but 9 into 10 power 9 if it is the displaced with the 8. Okay, so the second law will give the value or magnitude. So magnitude or value is given by second law, so the answer is option B. Okay, so first law will give the nature of force, second law will give the magnitude of force. Not only Coulomb's law, Faraday's law. First law will give the how the EMF is induced or how the voltage is induced, and second law will give the magnitude of that EMF. Now Newton's law. First law will give the definition of the force. Second law only will give the magnitude of the force. And according to Coulomb's law, Coulomb's law of charge, magnitude of force between two static charges is directly proportional to dash. Just now I have given. So according to the Coulomb's second law, the force is directly proportional to product of q1 q2 by d square. So the product of two charges. Okay, coming to the next one. What is the unit of electric current? Very, very, very important. What is the unit of electric current? Here current is defined as, current means, for example, if the water is flowing, you can say that is a water current. Okay, if any particle is moving, we can say that is that particle current. If the electrons are moving, we can say electric current. Okay, so the movement is nothing but we can say current. Okay, so we can say the flow of electrons or movement of electrons. Flow of electrons is nothing but we can say current. If the electrons are moving, there is a current is flowing. But how much of current is flowing? That is nothing but the current will give the fastness. Okay, the electrons are moving, okay, with how much fast they are moving, with how much rate they are moving slowly, they are moving very fastly, that is given by this current. Higher the current means higher the fastness, that is higher the momentum, very fastly moving. Lower the current means lower the momentum. So that means the current will give the idea of rate of flow of charge. Okay, so I is equal to rate of flow of charge. So it will give the idea how the charge is moving, slowly or fastly. If the time is less, the current is more. That means you can say within a less time it is moving means more current. If it takes more time, then the current is less. Okay, and current units are amperes, and charge units are coulombs, and time units are second. So ampere is equal to coulomb per second. So ampere is equal to coulomb per second. That is the another relation. And the units of current are ampere. Okay, coming to the next one. Which unit is equivalent to the coulomb? Which unit is equivalent to the coulomb? A very easy one. Just now I have given. Which unit is equivalent to the coulomb? Yes. Here just now we have discussed that 1 ampere is equal to 1 coulomb per 1 second. Okay. So from this 1 coulomb is equal to 1 ampere into 1 second. Now. 1 ampere into 1 second. So ampere second. Ampere second. Okay. Generally if you can consider the batteries. Batteries, how much of charge it is. So the capacity. So capacity is nothing but in the charging. If it is a fully charging or lightly charging. So charging, charge Q is equal to I into T. So I is ampere. Time is in case of second or hours. Ampere hour. So that's why battery capacity is always in ampere hour. AH. Ampere hour. Okay. Coming to the next one. A current of 0.5 amps is drawn by a filament of an electric bulb for 10 minutes. Then charge Q is equal to dash. Then the charge Q is dash. Just now I have given charge Q is equal to Q is in coulombs, current I is in amperes, time T is in seconds. Okay, 1 coulomb is equal to 1 ampere 1 second. Okay, so from this amperes 0.5 amperes, time in seconds, but they have given in the minutes, so 10 into 60 seconds, so 600 seconds. So that is nothing but 300 coulombs. Okay, so the answer is the option D. Don't forget to convert the time into second. Okay, if you forget that one, then you will get the answer as 5, which is wrong. Which is wrong. What enables the electric current to flow in a circuit? What is the meaning of current? Flow of electrons, movement of electrons. So that is nothing but motion of electrons. Whenever there is a motion of electron is there, then the current will be flows. That is that enables that current will be flow. So whenever we have the free electrons, if we have the free electrons, those free electrons don't have the work. So they are moving from one place to another place. That movement is nothing but we can say current. Okay. If we have the still water that don't have the current, so water is moving, we can say that is a water current. Okay, so if the electrons are just stay, so there is no current. Whenever the electrons are moving, then we can say that is a current. Okay, whenever there is a movement, that is only the we can say current. Okay, so that current also will give the idea how much of rate, that is how fastness the charge is moving. Okay, if the charge is moving fastly, current is very high. The charge is moving slowly, current is very slow. Okay, so I think all of you got. And if I is the current through a wire and E is the charge of an electron, then number of electrons crossing in t seconds will be given by dash. A very easy question. All of you try to give the answer. Okay, after that check with my answer. Current through wire is I, and charge of an electron. One electron charge is nothing but one electron charge is nothing but they have given E. If we have n number of electrons, then what will be the charge? Charge is equal to n into E. And we know very well current I is equal to rate of flow of charge. From this, charge Q is equal to I into T now. Charge Q is equal to I into T. Okay. So here the charge is n into E. Here the charge is I into T. So if you replace, if you equate these two, okay, then I into T is equal to n into E. They are asking the number of electrons crossing. So n. So n is equal to IT by E na. IT by. So we are getting the answer as IT by E, option C. So if electron charge is E, n number of electrons charge is n into E, and we know charge is equal to I into T. If you equate these two, I into T is equal to n into E, then we can get the answer. N is equal to IT by E. Okay. Coming to the next one. 1 ampere is equal to dash. 1 ampere is equal to dash. Ampere is the unit of current. Current is equal to rate of flow of charge. Okay, so ampere is the unit of current, but unit of charge is coulombs and time seconds. So from this relation we can get idea 1 ampere is equal to 1 coulomb per second. So the answer is option A. Coming to the next one, which opposes the flow of current is dash. Which opposes the flow of current is dash. That is capacitance, inductance, charge and resistance. Yes, here which opposes the flow of current, that is nothing but we can say resistance. The resistance opposes the flow of current. The symbol of the resistance is like this. If the current want to flow through the resistor is going to be opposes. So higher the resistance, higher the opposition, lower the current. Lower the current. And units are ohms. Units are ohms. Okay. And we can denote with a symbol like this. Which opposes the flow of current is nothing but resistance. Resistance opposes the current flow. Coming to the next one, resistance of wire is directly proportional to dash. Resistance of wire is directly proportional to dash. Area of the wire, length of the wire, current and all. Yes. Here this resistance is directly proportional to the length of the wire. That is more wire having the more resistance. The wire having less length, the wire having more length. Okay. So less length having the less resistance, more length having the more resistance. And this resistance is inversely proportional with area of the conductor. So if the area is more, then resistance is less. If the area is less, resistance is more. Okay, so inversely proportional with A. So if you combine these, R proportional to L by A, if you remove the proportionality constant, we have to take one constant, that is rho. So rho is the specific resistance. Specific resistance. It has a specific value. R resistivity. It is a fixed value, may not depend upon the physical quantities, depends only nature of material. So here directly proportional to length only. Area inversely proportional. Current also inversely proportional. So the answer is option B. Coming to the next one. When area of the conductor is doubled, then resistance will becomes dash. When area of the conductor is doubled, the resistance of the wire will becomes dash. Just now I have given the formula. The resistance is inversely proportional with area. If the area is going to be double and resistance will becomes half. Okay, inversely proportional na? Is it going to be double? It is going to be half. So the answer is option B. So the answer is option B. Coming to the next one. Average resistance of human body is dash 50 ohms, 1000 ohms, 10,000 and 20,000. Here in default, if they have given just average resistance of human body, we have to give 1000 ohms. Okay, in live condition or default case, that means if they have not mentioned anything, we have to give the answer as 1000 ohms. In case of dead, okay, or in case of dry condition, here you can say wet condition also. Dry condition, it has the 10,000 ohms. Why? Because all the fluids will be evaporated, so higher the resistance. So here just they have asking average resistance, that is 1000 ohms. Coming to the next one, the temperature coefficient of resistance of the wire is 12.5 into 10 power minus 4 per degree centigrade. At 0 degree centigrade, the resistance of the wire is 100 ohms. The resistance of the wire at 100 degrees centigrade will be dash. That means as the temperature changes, what happened to the resistance? What happened to the resistance? They have given temperature coefficient of resistance. This is the alpha value. And resistance at 0 degree centigrade, or at 0 degree centigrade they have given, and temperature T they have given. So at this temperature we require the resistance. We have the formula, resistance at T degree centigrade is equal to resistance at 0 degree centigrade into 1 plus alpha into T. So if you substitute the values, R at 0, 100 you have, 1 plus alpha value they have given 12.5 into 10 power minus 4 into temperature they are asking at 100 degrees centigrade. So 100 into 100 plus 100 into 100, 10 power 4, 10 power 4 into 10 power minus 4 getting cancelled out, you are getting 12.5. So that is nothing but 112.5 ohms. So the answer is option B. 112.5 ohm. So the answer is option B. Okay, all of you clear? So that means what you can say, at 0 degrees centigrade we have 100 ohms. At 100 degrees centigrade it will becomes 112.5. So in case of conductors, as temperature increases, resistance also increases. Why? Because the temperature coefficient alpha is positive. If it is negative, then you have minus here. Minus here means 100 minus 12.5, that is 87.5 we are getting, that is resistance is decreases. In case of semiconductors, that is inversely proportional. Semiconductor, as temperature increases, resistance is decreases. Okay. So here they are asking in conductor, that is a wire. Wire is nothing but a conductor, and alpha value is also positive. Okay. So like that you can get the answer. This is a very important formula. All of you note this formula. Okay. What is the first question? In the following, which is having low resistivity element? Copper, nickel, iron, Az. Az means silver. Okay. In the following, which is low resistivity element? Generally, they are asking the low resistivity or high resistivity elements in case of conductors. Okay. In case of conductors. So, in case of conductors are nothing but which allows the electricity. Which allows electricity. Okay. The resistivity is nothing but rho. It has a fixed value. In these conductors, coming to silver having very low resistivity. Okay. After that we have the copper. After that we have gold. After that we have the aluminum. So silver 1.57 into 10 power minus 8 ohm meter. Copper case 1.68 into 10 power minus 8. Somewhat of higher. Gold is nothing but 2.4 into power minus 8. Aluminum 2.6 into 10 power minus 8. Okay. So these are the top 4. In the same way, if you can consider very high resistivity cases, high resistivity elements. So in this, first of all, we have the carbon or allotrope of the carbon, that is you can say graphite. Graphite is having very high. After that, alloy, nichrome. After that, manganese. After that, constantan. Okay, those are the high resistivity elements in case of the conductors which allows the electricity. So low resistivity element is silver. What is the phenomena or what is the consequence if the resistivity is low? We know very well R is equal to rho L by A. If the resistivity is low for the given length and area, if the resistivity is low, the resistance is low. As the resistance is low, it can having the capability to flow the more current. So we can get the more current. Okay. So if you are getting the more current, that means you can say it is the best conductor. So silver is considered as best conductor of electricity. And low resistivity. If the resistivity is low, then sigma is considered as conductivity. That is equal to reciprocal of resistivity. If the resistivity is low, higher the conductivity. Okay. So we can consider the silver having low resistivity, best conductor of electricity, high conductivity. Okay. Coming to the next one. In the following, which is high resistivity element? Just now I have given, if they have given carbon, we have to select the carbon. Carbon is not there, we have to go for nickel. Okay. Coming to the next one, electrical conductivity of metal is typically in the order of dash. Conductivity is equal to reciprocal of resistivity. For example, let us take any one copper. Okay, 1 by 1.68 into 10 power minus 8 ohm meter. So 1 by 1.68, what is the value we are getting? 1 by 1.68. Let us calculate, all of you. 1 by 1.68, that is 0.59. 0.59 into 10 power 8. That means 5.9 into 10 power 7. Okay, 1 by ohm meter means mho per meter. Mho per meter or Siemens per meter. Okay. So 10 power 7 order. So in case of conductors, that is 10 power 7 order. So the answer is option A, 10 power 7 order. Okay. A wire of given material having length L and area of the cross section A has a resistance of 4 ohms. What would be the resistance of another wire of the same material having length L by 2 and cross section area of the 2A? Cross section area of the 2A. So in the second case, what will be the resistance? All of you try to find out. After that, check with my answer. Okay. First case, what they have given, listen carefully. Length L, area A, then resistance. The resistance is equal to rho L by A, na? That is 4 ohms they have given. In the second case, what is the L2 they have given? L is going to be changes as L by 2. Area 2 they have given as 2A, and same material. Whenever the material is same, resistivity is same. So resistivity is same. Then what is the resistance? Let us take that resistance R2 is equal to rho L2 by A2. Rho, in the place of L2 I am substituting L by 2. In the place of area 2 I am substituting 2A. So now you are getting rho L by 4A, that is rho L by A is nothing but resistance R by 4. So R2 will becomes R by 4. Okay, previously R is 4 means now it is the 4 by 4, that is equal to 1. So the answer is 1. Okay, so if the length is L by 2, cross section area is 2A, resistance will become resistance by 4. Previously they have given 4, 4 by 4, 10, 10 by 4, 20, 20 by 4, like that we will get the answer. Okay, coming to the next one. A wire of length L made up of material resistivity is cut into 2 equal parts. The resistivity of each part is equal to dash. A very good question. The resistivity of each part is equal to dash. Pause the video and think about the answer. After that, check with my answer. Okay, what is the point I have given? This resistivity is rho, depends only on nature of material. Nature of material. Okay, that is type of material. Which type of material you are using? Silver you are using, copper, aluminum. What is the material you are using? That is depend upon on that material only this resistivity depend. It not depends on physical quantity and also temperature, and it not depends on physical quantities. Not depends on physical quantities means it may not depend upon length, not depend upon area, not depend upon the value. So if the any wire, if you are going to take, okay, having a length L, the resistivity is rho, and if you cut into 2 equal parts, if you cut into 2 equal parts, for example, previously we have taken copper, this is a copper, this is also a copper only. Material is not changes. Am I correct? If you cut into a wire, the both wires having the same material. So same material means same resistivity only. Previously rho and same material means same resistivity only. Just length it changes, L by 2, L by 2. As the length changes, it may not changes. It may not depend upon the length. Clear? So as the length changes, resistivity may not changes. It is a constant only. Coming to the next one. In which of the following elements dissipates the electrical energy? Which of the following elements dissipates the electrical energy? Here we have 3 passive elements. Those are which are receiving the energy. The elements which receives energy, electrical energy, are nothing but we have 3 elements. Those are resistor, inductor, capacitor. Okay, so this resistor dissipates the electrical energy. Dissipates, that means consumes or absorb. It absorbs the electrical energy. So the answer is option B. And what about these two? These are stores the energy. Okay, so we can say storage elements. These two are storage elements. It stores energy like a water tank stores the water. Okay, so the answer is option B. What should be present in a substance to make it a conductor of electricity? To make it a conductor of electricity. So to make it a conductor of electricity, that means whenever there is The material which allows the electricity through that is nothing but, you can say, conductor. Okay, so if it want to allows the current or electricity through it, it must have the free electrons. It must have the free electrons. Okay, whenever we have the free electrons, then they are moving from one side to other side. So that means that movement of electrons is nothing but, you can say, current. So whenever we have the free electrons, that material can allows the electricity through it. So conductors, we have the free electrons, and in insulators we don't have the free electrons. So insulator may not allow the electricity. In conductors, as temperature increases, what happened to the resistance? In conductors, as temperature increases, what happened to the resistance? We have already discussed in the previous session. In the previous session, we have discussed this one. Here, whenever the resistance at 0 degree centigrade, we have resistance is 100 ohms only. Whenever the temperature is increases to 100 degrees centigrade, the resistance is going to be increases 112.5. That means as temperature increases, the resistance also increases. Okay. So finally, what we can say, in case of conductors, as temperature increases, the resistance also increases. Resistance also increases. Okay, but in case of semiconductors, it is reverse. Semiconductors, it is reverse. As temperature decreases, or as temperature increases, resistance is decreases. As temperature increases, the resistance is decreases. Okay, as resistance decreases, current will be increases. In case of semiconductors, in conductors, temperature increases, resistance also increases. So the answer is option B. Coming to the next one, what is the work done in moving a unit positive charge from infinity to that point is dash? Current, charge, resistance, and electric potential. It is nothing but a definition, students. It is nothing but a definition. So work done on unit positive charge is nothing but definition of electric potential. Definition of electric potential or voltage. That is work done by unit positive charge. Okay. So potential is denoted with the letter V. V is equal to W by Q. And potential units are volt. Okay. And work units are joule. Charge units are coulombs. So 1 volt is equal to 1 joule per 1 coulomb. 1 volt is equal to 1 joule per 1 coulomb. So the answer is option D. Potential is equal to work done on unit positive charge. Coming to the next one. Which of the following devices helps to maintain a potential difference across a conductor? Here, this ammeter, it is a meter. Watt meter, it is also meter. Voltmeter is also meter. What is the meaning of the meter? What is the purpose of the meter? Meter just measures. Okay, used for the measurement. Okay, so ammeter used for the measurement of amp. Amp is the unit of current. So ammeter is the ammeter is used to measure the current. Watt meter, watt, power. So used for measurement of power. Okay, and voltmeter used for the measurement of voltage or potential difference. Voltage or potential difference. Okay, but it may not maintain. If you want to maintain the potential difference, battery is required. The battery only can maintain the potential difference. For example, if we have one conductor, this conductor here also having zero potential, here also having zero potential. Whenever there is no potential difference, there is no flow of the current. Am I correct? Whenever there is a potential difference, then only current will be flow. Or in case of perfectly horizontal tube, water may not move whenever there is no pressure difference. If you make the pressure difference by creating the height difference like this, if you create some pressure difference, then water can easily move without any external force. Without any external force, water can easily move like this. Okay, so whenever there is a pressure difference, there is a water will be flow. Here also, whenever there is a potential difference, then current will be flow. Here there is no potential difference, no current will be flow. If you connect a battery here, for that conductor, if it is a 10 volt battery, Okay, here positive side 10 volt is created, negative side 0 volt is created. Now what is happening? 10 volt to 0 volt, there is a potential difference is there. Whenever there is a potential difference, then current will be flows. So as soon as the battery is connected, here this point is maintained 10 volts, this point is maintained 0 volt. That means it maintains a potential difference. So battery maintains a potential difference. Battery used to maintain the potential difference. Here meters are just to measure, they may not maintain anything, they may not produce anything. Okay, for example, if you can consider 1 liter milk can, 1 liter milk can, it can measure the milk. Okay, it just used to measure the milk, or it can measure the water. It can measure the water, it can measure the oil, 1 liter of milk, 1 liter of oil, 1 liter of water, but it may not produce that. It may not produce the water, it may not produce the milk, it may not produce the oil. So just meters are used for measurement only. Okay, so they may not maintain anything. So only the battery going to be maintain the potential difference. Which of the following law validates the statement that current flowing through conductor between the 2 points is directly proportional to the voltage across the 2 points? The voltage across the 2 points. Yes. Here the current flowing through the conductor is proportional to the voltage, or proportional to the voltage between the 2 points. That is nothing but we can say Ohm's law. Ohm's law. Okay. Or as you increase the voltage, then current flowing also increases. That is also can say Ohm's law. So if you remove the proportionality constant, we have to take a constant. That constant is the R. V is equal to I into R. V is equal to I into R. So that is nothing but Ohm's law. Very, very important, friends. As you increase the voltage, then current also increases. Or as you increase the current, then there is a high potential difference between the 2 points. Okay, that is nothing but Ohm's law. Which of the following formula states the relation between current, potential difference and resistance? Current, potential difference and resistance. We have already discussed according to the Ohm's law, V is equal to I into R. This is the relation between potential difference, current and resistance. From this, you can make this one as R is equal to V by I. R is equal to V by I. So this is the relation between these three. So R is equal to V by I. So answer is option A. Coming to the next one, 1 volt is equal to dash. 1 volt is equal to dash. In the previous session, I have given the units of voltage or potential difference. Voltage or potential difference units are nothing but volt. Nothing but volt. And what is the formula of this potential or voltage? Work done on unit positive charge. Work done on unit positive charge. So work done units are joule and charge units are coulomb. So voltage units are volts. So from this equation you can say 1 volt is equal to 1 joule per 1 coulomb. So joule per coulomb, answer is option B. Coming to the next one, students, how much work done in moving a charge of 2 coulombs across 2 points having the voltage 12 volt. Having the voltage 12 volt. Okay. So here they are asking the work done. And they have given charge Q is equal to 2 coulombs and voltage is equal to 12 volt. Okay. Voltage is equal to 12 volt. They are asking the work done. Just in the previous question, we have discussed voltage is equal to work done by positive charge. So from this, work done is equal to V into Q now. V is 12, Q is equal to 2 coulombs. That is 24 joules. So the answer is option C. Okay, enough you clear. So I have already given this formula. So from this one, we can say that the formulas are very important. If you have the formulas, we can get the relations. Okay, if any of the two quantities they have given, we can find out the third quantity. And we can get some relationship inversely or directly proportional relationship. We can get the units also. Okay. What will be the effect on the current flowing through a conductor if the resistance is double and the potential difference remain constant? As the resistance is going to be double and potential difference remains constant, what happened to the current? We know very well, as per the Ohm's law, current is equal to V by R. If the voltage is constant, if the voltage or potential difference is constant, if the numerator is constant, then I is inversely proportional with resistance. Inversely proportional with resistance now. Okay. Now they have given resistance is double. If this resistance is double, current is inversely proportional means current is going to be off now. The resistance is going to double, current is going to be up because of inversely relation, inversely proportional. Okay, and potential difference they have given constant. Then I is inversely proportional with R. R increases 2 times, I will be decreases by 2 times. Dash at a point defined as a force experienced per unit positive charge at point placed in a electric field. Placed in electric field. It is nothing but definition. Definition of electric field intensity, that is denoted with the letter A, denoted with the letter E. E is equal to force experienced by unit positive charge. By unit positive charge. Force by unit positive charge is nothing but electric field intensity. The units are Newton per Coulomb, or we have the other formula, voltage by distance or voltage by length, or voltage by length. Then units are volt per meter. These are the two units. Okay. Force experienced per unit positive charge is nothing but electric field intensity, option B. Coming to the next one, Ohm's law is not applicable to dash. Ohm's law is not applicable to dash. We have already discussed about this Ohm's law. What is the Ohm's law? Here, as we increase the voltage, then current also going to be increases. Or as the current increases, the potential difference is going to be increases. If you remove the proportionality constant, you are getting R. So V is equal to I into R. This is the Ohm's law. But it is applicable only for conductor. Applicable only for conductors and at constant temperature. At temperature as constant. At constant temperature. Okay. So whenever the temperature is constant, then voltage proportional to current. That is, as you increase the voltage, current also increases. That is nothing we can say Ohm's law. But it is not applicable. It is not applicable to insulators. For insulators, it is not applicable. Okay, as voltage increases, current may not increases like linearly or proportionally. Insulators and semiconductors and also electrolytes. So insulators means which may not allow the electricity. For example, wood, rock. Wood means dry. Okay, rock, any plastic may not allow the electricity. Semiconductors, the materials made with silicon and germanium. Example, diodes, transistors. For all these, Ohm's law is not applicable. Electrolytes, for example, H2SO4, and vacuum tubes. For all these, the Ohm's law is not applicable. So that is nothing we can give the answer as option D. Option D. Okay. A multimeter cannot measure dash. A multimeter cannot measure dash. As the name itself, students, multi, it can measure so many. Okay, so generally the very important point coming to the quantity. Okay, so all of you note it down, very important quantity and that units and the meter used to measure. Okay, so first of all, coming to the current units are amperes. Okay, as the unit name itself, we have the meter, ammeter. Ammeter is used to measure the current. Okay, and this ammeter always connected in series. Always connected in series to measure the current. And coming to the voltage or potential difference. Or potential difference. The units are volts. And the meter used to measure as the unit name itself, voltmeter. This voltmeter is always connected in parallel or shunt. Okay, or shunt means parallel only. Coming to the next one, resistance. Okay, resistance units are ohms. measured by, as the unit name itself, ohm meter. Power, electrical power. Power units are watts, watt meter. Energy, electrical energy, kilowatt hour, energy meter, energy meter. Okay, so by using the multimeter, you can measure all this. Multimeter, you can measure current, voltage, and resistance. Okay, but may not measure the frequency. So it can measure, it can measure, it can measure, but it may not measure. So that means the answer is option D. Frequency, we have the frequency meter, and we can use the bridge type of the meters also. That is nothing but wheel bridge is also used to measure the frequency. CRO, cathode ray oscilloscope, is used to measure the frequency. Frequency, frequency meter, or you can use the CRO, you can use the wheel bridge. Okay, so these are used to measure the frequencies. If you want visual representation, here we can use CRO for visual representations also. So all of you getting current, ammeter, voltage, voltmeter, resistance, ohm meter, power, wattmeter, energy, energy meter. Multimeter can measure all this current, voltage, and resistance, but may not measure the frequency or phase angle. Frequency or phase angle, it may not measure. Ammeter should always connected in dash to the circuit. Just now I have given ammeter should always connected in dash to the circuit. For example, if it is one bulb, if you want to know the current flow through the bulb, we can connect one ammeter here or here. You can connect here or here, whatever it may be, starting or ending. Then what is the whatever the current is flowing through the bulb, the same amount of the current is flowing through the ammeter also, so it can measure. So always connected in series. Okay, series. In case of voltmeter, what I have given, for example, if it is a bulb, if you want to measure the voltage across the bulb, okay, voltage or potential difference. If you want to get the difference, you require 2 points. So I am going to connect the voltmeter between the 2 points like this. Now it can give the potential difference between the 1 and 2 points, 1 point, 2 point. So that means voltage is connected always parallel. Voltmeter is always connected parallel. Okay. So ammeter in series. Conductance is a reciprocal of dash. Conductance is a reciprocal of dash. Conductance is a reciprocal of resistance, friends. Resistance means opposes, conductance means allows. That is a simple definition. Resistance is opposed to the flow of current. Opposes the current. Conductance is allows the current. The property which can allows the current through. So both are inverse. So resistance is denoted with the letter R and conductance is denoted with the letter G. So from this, G is equal to 1 by resistance. G is equal to 1 by resistance. And conductance units are mho or Siemens. Mho or Siemens. Resistance ohms. Okay. Mho symbol is like this. Here 1 by R is nothing but, can say 1 by ohm. 1 by ohm is nothing but mho or Siemens. Okay. So once again, resistance and conductance. In the same way, resistivity. Resistivity is property of the material. Resistivity denoted with the letter rho. Okay. So rho units are ohm meter. Ohm meter. And same reciprocal is nothing but conductivity. Conductivity, that is sigma. Sigma is equal to 1 by resistivity. That is 1 by ohm meter. 1 by ohm is nothing but mho. So units are mho per meter. Or mho can be replaced with Siemens. Siemens per meter. Mho per meter or Siemens per meter. Okay, so conductance is the reciprocal of resistance. Coming to the next one. Conductance is expressed in terms of dash. Just now I have given conductance. Conductance is G. Okay, units are mho or Siemens. Mho or Siemens. Okay, so the answer is option B. Coming to the next one. Resistivity is expressed in terms of dash. This point also have given na? Resistivity is expressed in terms of dash. Resistivity, rho, okay, rho units are ohm meter have given. So ohm meter, for example, if you have forgotten this one, then also you can get from the resistance formula. So rho is equal to RA by L. So R, resistance is ohms, area meter square, length meter. So 1 meter is get cancelled out. You are getting ohm meter. Clear? You are getting ohm meter. Now the question is belongs to series and parallel connection of the elements. If two resistors of 100 ohms, 100 ohms are connected in series, then combined resistance will be dash. What is the combined resistance? Here, before going to give the answer, I want to give the information about the series connection of the resistors. Okay, so series connection, note down all these important points. All the points are very, very important. First point, if the resistors are connected in series like this, okay, one end of the resistor is connected to starting of another one, R1, R2, and so on, Rn, then in this case, the total resistance is equal to sum of all the resistor values, R1 plus R2 plus and so on, Rn. That means total resistance will be higher. Total resistance will be increases. If you add the resistors in series, the total resistance is increases. The second point, if in case of series resistors, the current flowing through all the resistors is set. Let us take I1 is current flowing through R1, is I2, it is IN. Then you can say it is a total current. Total current is equal to sum of all the currents. Sorry, equal to the current through all the currents. Okay, so same current is flowing. For example, here 5 amps is flowing, the total current. Through R1 also 5 amps only flowing, through R2 also 5 amps flowing, through Rn also 5 amps is flowing. That means you can say in series connection, current is same. Current is same. And coming to the third point, that is nothing but voltage across, voltage drop is different. Why? Because if the resistance is different, I into R1 is the voltage, I to R is the voltage, I and Rn is the voltage. So it is the V1, it is the V2, it is the Vn. So voltages are not equal. Voltages are not equal because resistors are not equal. If the resistors are equal, voltages are also equal. Okay, voltage drops are also equal. So the total voltage is equal to sum of the voltages. Okay, so here current is same, but voltage is going to be added. Voltage, the total voltage is nothing but sum of the all the voltages. Okay, so we know the Ohm's law, V proportional to I, or V is equal to I into R. In series connection, current is same now. If this current is same, then you can say voltage drop is directly proportional to the resistance. Voltage drop is directly proportional to the resistance. Higher the resistance value, higher the voltage drop. Okay, this is also very, very important point. Note down this point. Okay, note down this point. So first point, total resistance is sum of all the resistors. Current values are same current is flowing. Third point, voltages are different if the resistors are different. So total voltage is equal to sum of all the voltages. So here in this connection, in this question, they have given series connection. In the series connection, what is the answer? Series connection, they have given each resistor 100 plus 100, that is equal to 200. So the answer is option C now. So the answer is option C. Okay, very, very easy. But coming to the next one, if two resistors of 10 ohms are connected in parallel, then what will be the combined resistance? In parallel case, I want you the question, I want you the points like previous in case of parallel connection also. Okay, note down this parallel connection. Here starting end is connected to another starting end, ending is connected to another ending. Okay, it is the R1, it is the R2, it is the Rn. Here if it is a total current, the current is divided as per the resistors. Higher the resistance, lower the current. Okay, higher the resistance, lower the current. Okay, like that. So here across all the elements we have same potential difference. Voltage is same. Why? Because whatever the voltage here, the point is connected to here, this point is connected to here, so same voltage drop across this one, same voltage drop across this one, same voltage drop across this one. So voltage drops are same. Let us take it is the V1, V2, Vn, all are equal to Vt. And coming to the first point, in case of parallel connection, the total resistance we have to take all are in the reciprocal. 1 by R total is equal to 1 by R1 plus 1 by R2 plus and so on 1 by Rn. Okay, here the very important thing is nothing but if R1 is equal to R2 is equal to and so on Rn, all the resistors are equal, that is let us take that is R, then 1 by R total is equal to 1 by R plus 1 by R plus 1 by R plus and so on n times, that is you can say n by R. Okay, so from this R total is equal to R by n. If n number of resistors are connected in parallel, okay, then total resistance is going to be decreases with n times, decreases with n times. If the two resistors are added of the same resistance, that will be decreases by 2 times. 4 resistors decreases by 4 times. Okay, that is the meaning of this one. Very, very important point. For example, in this question also, they have given same resistance, and then what is the total resistance in parallel case? The resistor value by number of resistor. The resistance is 10. How many number of resistors are there? 2 resistors. So 5. So simply we can get the answer. Or by using this formula also can get 1 by R total is equal to 1 by 10 plus 1 by 10. If you calculate also, you will get 5 only. That means 10 to 5, it is decreases now. 10 to 5, it is decreases. In case of series, it is increases. Okay, 100 to 200 increases. Okay, and the second point here. Here currents are different. Total current is equal to sum of all the currents. Different. If the resistance are different. Okay, and the third point, here voltages are same. Total voltage is equal to V1 and so on, V2 and so on, Vn. Okay, so voltages are same in our potential difference, our voltage difference are same in parallel connection. Okay, series connection currents are same, parallel connection voltages are same. Series connection voltages are different, parallel connection currents are different. Okay, that is what is the difference. Coming to the next one, students. When two resistors are connected in parallel, they have dash. When two resistors are connected in parallel, they have dash. A very easy one. In the parallel case, what is the same? Potential difference is same. Voltages are same. Potential difference. Voltage difference is same. Okay. So we can say same potential difference. So the answer is option B. Same potential difference. So the answer is option B. Okay. Students, if you like my class, please give a comment. Okay. That will encourage me a lot. If 20 resistors of 100 ohms each are connected in parallel, then combined resistance will be dash. Combined resistance means total resistance. Okay, so in the previous session I have given the formula. If the same resistance value connected in parallel, what will be the combined resistance? Let us take that previous one. So in parallel connection, R total is equal to R by N. Same value of the resistance by number of resistors. Okay, so if you use that formula, you will get the answer very easily. Resistance is the 100. How many resistors connected? 20. So the answer is 5. Very easy one. Okay, we don't want to take like 20 resistors are in parallel like this. Okay, and we have to calculate 1 by R total is equal to 1 by 100 plus 1 by 100 plus 1 by 100 plus and so on. Okay, 1 by 100 in 20 times. Okay, so it is some lengthy. So if you use the shortcut formula, R total is equal to R by N in case of parallel. If they have given the same question in series, what is happening? We have to multiply. Resistance is increases now N times into R. N times into R. Here R by N. Okay, so the answer is option C. Very, very easy one. Coming to the next one. If three resistors of 100 ohms, 200 ohms, 300 ohms are connected in series, which resistor have high voltage drop? High voltage drop. This one also have explained in the previous. Okay, try to give the answer. After that, check with my answer. So what is the point I have given here? In case of series connection, current is same. So voltage drop is directly proportional to resistance. So higher the resistance, higher the voltage drop. Na? So let us take that point here. In series connection, current is same. Okay, so as per the Ohm's law, V is equal to I into R. If the current is the same, constant, okay, so the voltage drop is directly proportional to resistance. Higher the resistance, higher the voltage drop. So in this 100, 200, 300, higher the resistance is 300, so the voltage drop also higher in the 300. Okay, so if you want to understand in detail, that is also very easy one only. 100, 200, 300. Okay, so let us take any value of the current. Let us take 1 amp or 2 amp, 3 amp, or take as I. Okay, 1 amp let us take. Then what is the voltage drop here? Voltage is equal to current into resistance. 1 into 100, 100 volts. 200 into 1, 200 volts. 300 into 1, 300 volts. So where is the higher drop? Across the 300 volts. So the answer is option C now. Coming to the next one, students. If the two capacitors of 10 microfarad, 10 microfarad connected in parallel, then combined capacitance will be dash. Whenever there is a capacitor, we have to be careful, guys. Why? Because capacitor formulas are different from resistor and inductor formulas. Okay, so I want to give again, the resistor and inductor formulas are same. In series connection, just we are added R total is equal to R1 plus R2 plus and so on. Okay, and L total also equal to L1 plus L2 plus and so on. And whenever coming to the parallel case, reciprocals are added now. 1 by R total is equal to 1 by R1 plus 1 by R2. In the same way, 1 by L total is equal to 1 by L1 plus 1 by L2 and so on. So parallel case, reciprocals are added. Series case, absolute values are added. But whenever coming to the capacitor, different. Okay, so we know very well in our family, if the last child is a girl, if the girl child we have, that is a last child, she is always doing some different. Okay, if the older son, or that is nothing but can say, if we have three children, in that one is the resistor, one is the inductor, one is the capacitor. Here this last child is there now. If the father taken five apples, then she want three. The remaining one will be given to other. She always doing like that. She is different. Okay, so she is always different, friends. Okay, different from the R and L. So that means here the connections also, series connection, reciprocals are added. 1 by C total is equal to 1 by C1 plus 1 by C2. In parallel case, direct values are added, C1 plus C2. So these are the formulas for capacitor, inductor and resistor. Okay, all of you make a note. Here combined capacitance in parallel case. In parallel case, C total is equal to C1 plus C2. C1 plus C2 means 10 microfarads, 10 micro, 20 microfarad. So the answer is option B. In case they are asking series connection, then it will be 10 by 2, that is equal to 5 you will get. Okay, 5 you will get. If you want, you can check. Okay, so in this parallel connection, sorry, in the series connection, the total capacitance is equal to C by N. Here, if the values are same, C total is equal to N into C. These are the shortcuts, like in the previous we have discussed. Na? So if they have given series, capacitance 10, how many capacitors? 2 capacitors. 10 by 2, that is equal to 5. Here in parallel case, N into C, that is 20 micro. Coming to the next one, students, units of capacitance. Units of capacitance. Here capacitance or self-capacitance or mutual capacitance. Okay, for all these the units are farad only. The units are farad only. So the answer is option D. Okay, coming to the next one. Capacitance value is not depending on dash. Capacitance value is not depending on dash. Very, very good question. Here capacitance, how the capacitance is going to be formed? Simple, friends. If you have two charged plates, this is the one charged plate, another charged plates, these are displaced with some distance, or the distance may be having any insulator, that means you can say any dielectric epsilon, this dielectric means which may not allow the electricity through that. For example, you can say air, paper, mica. Okay, all these are nothing but you can say dielectrics. If this plate area is A, okay, plate area is A, whenever you displace the two charged plates, it is a one charged plate, it is another charged plates, displaced with some air or paper or any other dielectric, then there is a capacitance is formed. That capacitance is depends upon this nature of dielectric and area of the plates and distance between the plates. If the distance is less, capacitance is more. If the distance is more, the capacitance is less. Inversely proportional with the distance or separation. D is nothing but you can say separation between plates. between plates. Okay, so it depends upon nature of dielectric, yes. Area of the plates, yes. Distance between the plates, yes. But it may not depend upon the thickness of the plates. So we can use the answer as option D. So we can use the answer as option D. All of you clear? Coming to the next one. Which of the following relation between the capacitance, charge and potential is true? Potential is true. A very easy question. If we have the capacitor, the value of the capacitor is C. If we have the voltage across the capacitor, if you give some voltage to the capacitor, then what is happening? Capacitor is a storage element. I have already given now. Resistor dissipative, capacitor inductor storage element. So this stores energy in charge format, electrostatic format, charge format. The charge stored is equal to depends upon the applied voltage and depends upon the capacitance value. More capacitance, more charge is storing. Okay, for example, I have given capacitor is act as a tank. Okay, if the C is more, it is a bigger tank. Bigger tank means it can store so much of water. Lesser tank or lesser capacitor, it can store less amount of the charge. Okay, so this charge Q is equal to depend upon the C and V. Q is equal to CV. Okay, Q is equal to CV, which does not allow the sudden changes in voltage. Does not allow the sudden changes in voltage. Here we have already discussed that inductor and capacitor are storage elements. Storage elements. Because of stored energy, whenever there is a sudden changes, they may not allow. They may not allow the sudden changes. So here inductor not allow sudden changes in current. Sudden changes in current. Okay, capacitor not allow sudden changes in voltage. Sudden changes in voltage. So here they are asking the voltage. They are asking the voltage. That is nothing but in case of voltage case, that is the capacitor. So the answer is option C. Coming to the next one. Which of the following expression gives energy stored in the capacitor if C is the capacitance and V is the potential and Q is the charge? C is the capacitance, V is the potential and Q is the charge. So the energy stored in capacitor EC is equal to half CV square. Half CV square. In the same way, energy stored in inductor EL is equal to half Li square. Okay, so inductor is the current phenomena, capacitor is the voltage phenomena. It stores energy in charge format, it stored energy in magnetic format, electrostatic format. It stores energy in electromagnetic. Okay, so here they are asking in case of capacitor, that is half CV square. Half CV square, so the answer is option B. Coming to the next one. In the following, which does not allow the sudden changes in current? Which does not allow the sudden changes in current? We have already discussed which does not allow the sudden changes in current is nothing but inductor. Units of inductance. Units of inductance. If they are asking self-inductance or mutual inductance, whatever it may be, the units are nothing but Henry. So the answer is option B. Coming to the next one. Inductor stores energy in the form of dash. Inductor stores energy in the form of dash. Just now I have given inductor stores energy in the electromagnetic form. Capacitor stores energy in static form. Inductor resistor may not stores energy, it dissipates the energy. Why batteries are connected in parallel? In parallel, the voltages are same. Okay, if you connect the batteries in the parallel connection, voltages are same. Same voltage will be across the two batteries, but currents are going to be added. Currents are going to be added. I1, I2, total current is equal to I1 plus I2. So the total current is going to be increased. So we are going to add batteries in parallel to increase the current rating. To increase the voltage rating, we have to add them in series connection. Coming to the next one. If current through the resistance is 0.5 amps and resistance is 500 ohms, then voltage across the resistor is dash. We know the Ohm's law. What is the Ohm's law? V is equal to I into R. So V is equal to I is nothing but 0.5 and resistance is nothing but 500. So that is nothing but half of the 500, 250 volts. So the answer is option C, 250 volts. So the answer is option C. Coming to the next one, 1 watt is equal to dash. 1 watt is equal to dash. What is the unit of power? What is the unit of power? And power is equal to energy by time. Energy by time. So 1 watt is equal to energy. Joule by time means nothing but second. So joule per second. So the answer is option D. Joule per second. So the answer is option D. Coming to the next one. Which of the following terms does not represent the electrical power in the circuit? Which of the following terms does not represent the electrical power? Electrical power formulas. Coming to the first formula of the electrical power, product of voltage into current. Product of voltage into current. In the second formula, you can say in terms of voltage, we have to substitute the V is equal to I into R. I into R into I. So power P is equal to I square into R. So this is the second formula of the power. Whenever they have given current and resistance, you can use this formula. So VI is also correct only, I square R also correct only. And coming to the third formula, P is equal to V into I. In this, I'm going to substitute I is equal to V by R now. So I'm substituting in this one V by R, V square by R you are getting. So this is the third formula of the power. This is the second formula of the power. So V square by R also correct only. IR square is wrong. So you can give the answer as option C. You can give the answer as option C. The current I flows through a resistor. A source maintains a potential difference of V across the resistor. The energy supplied by the source in time t is dash. The energy supplied by the source in time t is dash. Here the electrical energy formula, energy is equal to power into time, guys. Power into time. Okay. So this power is nothing but, you can say, product of voltage into current, and this is the time. Okay. So the energy is equal to VIT. Energy is equal to VIT. So the answer is option C. So the answer is option C. Okay. Very, very easy one. Coming to the next question, guys. If current through resistance is 0.5 amps and resistance value is given by 500 ohms, then power dissipated in resistor is dash. Power dissipated in resistor is dash. Here they are asking the power dissipated in resistor. Power P is equal to product of voltage into current. That is a one formula. If they have given current and resistance I square R, that is the another formula. And one more formula V square by R. Here they have given amperes, that is current, and resistance R. Current and resistance we have means we can use this formula now. Power is equal to I square into R, that is 0.5 whole square into R, that is 500. That is 1 by 2 whole square, 1 by 4. 1 by 4 into 500, 125 watts. Okay, so the answer is option B. Power B is equal to I square into R. If you substitute the values, you can get the answer easily. Okay, coming to the next one, guys. If voltage across the resistance is 200 volts and resistance value is given by 100 ohms, then power dissipated in the resistor is dash. Power dissipated in the resistor is dash. Very easy one. Power dissipated in the resistor. Here they have given voltage and resistance is 100. Then what is the power, guys? Power is equal to V square by R na. So that is 200 whole square into R, that is 100. So 200 into 200 by 100. 100 ones, 100 twos, that is nothing but 400 watts. So the answer is option B now. So the answer is option B. So if you know the formulas, it is very, very easy to give the answer. Coming to the next question, guys. Students, if you like my class, please click on like button and also please share the information to all of you. And if you click on description box, you can get my Telegram link and you can also join in that Telegram link. Okay. If current through resistance is 0.5 amps and voltage is 230 volts, then power dissipated in the resistor is dash watts. Power dissipated in the resistor is dash watts. Here they have given current 0.5, voltage 230. Then what is the power? Power is equal to product of voltage into current. Voltage 230, current is 0.5. Half of the 230, 115 watts. So the answer is option B. So the answer is option B. Okay, clear? Coming to the next question, guys. Calculate the current drawn from a generator having voltage output of 220 volt when connected to a load of 1100 watt. 1100 watt. So they have given load of 1100 watt. Watt means nothing but power now. So they have given the power and given the voltage. Then asking the current. We know the formula power is equal to product of voltage into current. So if you want current, power by voltage, power 1100, voltage 220. Once, twice. So that is equal to. So the answer is option D. So the answer is option D. All of you clear? So very easy one. Very easy question. So formulas are very important to solve the numericals. And a battery of 10 volt carries 20,000 coulombs of the charge through a resistance of 20 ohms. The work done in 10 seconds is dash. The work done in 10 seconds is dash. Here they are asking work done in 10 seconds. Voltage given and charge given. Any formula we have voltage, work done and charge relation. Yes, we have now voltage is equal to work done by unit positive charge. From this, work done is equal to voltage into charge. Voltage is nothing but 10 volt and charge is nothing but 20,000. Okay, so that is 2 into 10 power 5 joules. 2 into 10 power 5 joules. Okay, so if they have given another resistance and time, those are just not needed to confuse you only. Whatever we require, we have to use those values only and we have to get the answer. Okay, coming to the next one. A boy records that 4000 joule of work is required to transfer 10 coulomb of charge between the 2 points of a resistor of 50 ohms. The current passing through it is dash. The current passing through it is dash. Here we current formula. So rate of flow of charge. This is one formula. I is equal to V by R. This is the one formula. So let us check here voltage. They have not given. Resistance, yes, given. So voltage formulas now. Voltage V is equal to W by Q. Is there any W given? Yes, work given. And charge given? Yes, charge also given. So we can use this formula now. So I is equal to V by R. So in the place of V, W we have W by Q into R. So W is nothing but 4000 by charge Q is nothing but 10 coulombs and resistance is 50. 0, this 0, this 0, this 0, 5 ones, 5, 8. So that is nothing but 8 amps. So the answer is option C. So the answer is option C. All of you clear? The potential difference between the terminals of an electric heater is 60 volt when it draws the current of 4 amps from the source. What current will the heater draw if the potential difference is increased to 120 volt? Increased to 120 volt. So what is the question here? Potential difference 60 volt. If the voltage is equal to 60 volt, then the current is 4 amps given. If the voltage or potential difference is increased to 120 volt, okay, then what happened to the current there? What happened to the current? As the voltage increases, what happened to the current, friends? Here we know very well electric heater is nothing but it has a resistance, but it may not changes. So as per the Ohm's law, V is equal to I into R. As R is constant, voltage proportional to the current. As you increase the voltage, current also increases by same proportionality. So voltage will be increases from 60 to 120. That is, it is increases by 2 times means current also going to be increases 2 times. That is 8 amps. That is 8 amps. So the answer is option B. So the answer is option B. Okay. So it is nothing but a simple Ohm's law based question. Coming to the next one, guys. The next one, just wait a little. Okay. Now coming to the next one, guys. An electric bulb is rated 220 volt and 100 watts. When it is operated on 110 volts, then what is the power consumption? What is the power consumption? Okay. So they have given voltage as 220 volt, then power is equal to 100 watt. If the voltage is going to be reduced by 110 volt, that means half. What happened to the power? What happened to the power? What is the relation between power and voltage in terms of any resistance? Power P is equal to V square by R. Here same electric bulb means same resistance. So as R is same, then what is the relation you have? Power is directly proportional to V square. So as the voltage is going to be off, as the voltage is going to be off, then power will becomes V by 2 whole square. So that is nothing but V square by 4. That means power will becomes P by 4. Okay, power will becomes P by 4. So now the power is nothing but P by 4. In the previous it is a 100 watts. 100 watts by 4, that is just 5 watts. So the answer is option D. Okay, so as the voltage is decreases by half, the power is decreases by 4 times. Okay, so that is 100 by 4, then you are getting 25 watts. Coming to the next one, guys. The device used for producing the electric current. Producing the electric current, not measuring RC. Okay, producing the electric current. Here, which can produce the electric current or which can generate the current? Generate, that is nothing but produce, nothing but generator. Generator is used to generate the electrical current. Okay, and remaining these are nothing but meter. This is the meter, this is the meter. So meters are nothing but used for measurement, may not produce, just those are measures only. Okay, for example, if we have 1 liter can, 1 liter measurement can or measurement bottle measures 1 liter milk or 1 liter water, like that, but it may not produce 1 liter milk or 1 liter water. So like that, these are meters used to measure the currents, small currents. Okay, galvanometer used to measure the small currents and voltages, ammeter used to measure the currents, and motor producing mechanical energy. Mechanical energy. Okay, so the answer is nothing but generator. Coming to the next one, guys. A device which reverses the direction of current flowing in a circuit. Which reverses the direction of current flowing in a circuit. Just now I have given meter, just nothing but used to measure only. Okay, used to measure only. And resistor opposes the current, and it reverses the current. It reverses the current. So that means it can convert AC to DC or DC to AC. Okay, so that is nothing but commutator. So this is used in case of DC generators or DC motors. DC generator converts AC to DC, DC motor converts DC to AC. Okay, coming to the next one, guys. At the time of short circuit, the current in the circuit is dash. At the time of short circuit, the current in the circuit is dash. Let us understand, this is a simple topic. For example, let us take one bulb is there. Okay, so if you apply the voltage, then current is flowing. Then bulb will be closed. Okay, here bulb having some resistance. This bulb having some resistance. Okay, so based on the resistance, there is a current will be happen. I is equal to V by R. So here bulb having some resistance. Now, due to that, we are getting the I value, that is limited. I value is limited. If it is a short circuit, for example, whenever there is a short circuit means a wire is connected between the positive and negative. So if the wire is connected, a wire is nothing but can say short circuit. Okay, so whenever the positive negative directly connected, then current will flow through this one only. Current may not flow through the bulb. Okay, so this short circuit having very less resistance. Short circuit resistance is very less, almost less. Okay, so if the resistance is less, the current value will be very high, very high. So it increases heavily. So we can give the answer as option C. Increases heavily. Coming to the next one, guys. 100 joules of heat is produced each second in a 4 ohms resistance. Find the potential difference across the resistor. Okay, just wait. Heat energy given. What is the heat energy formula? H is equal to I square R into T is equal to 100 joules they have given. And resistance value also given. 4 ohms, and the time each 1 second given. Potential difference, voltage. What are the voltage formulas? Voltage is equal to work done by unit positive charge. Unit positive charge, but we don't have any charge. And what is the another formula? Voltage V is equal to I into R. There is a R is there, we don't have I, but we can get the I from this equation now. From this equation, from this, 100 joules is equal to I square. R is 4, T is 1. So 4 ones, 425. I is equal to 5. I is equal to 5. So if you are getting the I is equal to 5, then 5 into that resistance is 4, then you are getting 20 ohms. So sorry, 20 volts. Voltage units are volts. So that is nothing but 20. So the answer is option. So the answer is option. All of you clear? Coming to the next question, if the two bulbs of A bulb is 100 watts to 100 volts, B bulb having 60 watts to 100 volts rating are connected in series, then which bulb glows brighter? Which bulb glows brighter? Okay, so here a very simple one is nothing but in case of parallel. For example, in our houses, in our house connection, in our house, the bulbs are connected or any loads are connected in parallel. So that's why you can observe that that is generally 12-watt LED bulb gives more brightness than 8-watt LED bulb. So that means high power rating gives more brightness, gives more brightness. Okay, so for the same voltage rating, here all this calculation for same voltage rating. And in the same way, in series connection, here it is opposite. Series connection opposite. That is 12-watt LED bulb consumes less power than 8-watt bulbs. Okay, so that means low power rating gives more brightness. Gives more brightness. So here we have to check series connection or parallel connection. So series connection, so that is nothing but low rating bulb. So this is a low rating bulb, so can give the answer as option B. That is a simple analysis. No need to find out the resistance of the bulb. And in the series connection, generally the concept is in series connection, the power is equal to I square into R we are using. Current is same. So power is proportional to resistance, more power consumption, more brightness. That is the concept. Okay, so we don't need to find out the resistance of the each bulb and which is higher and which is gives the more brightness. That is some long process. Okay, so instead of that one, we can simply get the idea in practically in our houses we are using parallel connection. So high rating bulb gives the more brightness, less rating bulb gives the less brightness. So that is in case of parallel. In case of series, just opposite. Just opposite. Low rating bulb gives the more brightness. And coming to the next one. Here, if the two bulbs are connected in parallel case, what is happening? Which bulb glows brighter? Parallel case, high rating bulb. High rating bulb is nothing but option A. So we can give the answer as option A. That is high rating 100 watts. Coming to the next one, guys. In the following, which bulb having the high resistance? High resistance. Here, find out each and every one. In case of option A, what is the formula? We know very well power is equal to V square by R. So if you want resistance, R is equal to V square by P. So V is nothing but 200 into 200 by power P is equal to 200 watts. That is nothing but 200 ohms. And the second bulb, R is equal to V square by P. 100 into 100 by 100. So you are getting 100. So if you are doing like this, you will get for the C 50, for the D 25. Okay, so now which is the high resistance? That is nothing but option A is the high resistance. Option A is the high resistance. Like that, you can get the answer. And coming to the next one, the curve representing the Ohm's law. We have already discussed the Ohm's law, V proportional to I, or V is equal to I into R. So if you can consider this one, voltage and current. As the voltage increases, the current also increases. Here the slope is nothing but resistance. R is equal to V by T. Okay, that is nothing but can say slope. So here we are getting the curve passing from origin, and it is a straight line passing from the origin. So that is nothing but can say linear curve. That means as the voltage increases, the current also increases. Okay, so that is a linear curve. Coming to the next one, guys. Which of the following is not a type of energy source? What is meant by energy source which can use energy? That is nothing but energy source. Here generator, yes, it gives electrical energy. It is also gives electrical. It is also gives electrical energy. But rheostat is nothing but not a energy source. So the answer is option D. Rheostat is nothing but you can say a variable resistance. A variable resistance. Okay, here we have one long coil we have. In this one sliding contact is there. So if you change your sliding contact, if you change your sliding contact, then your resistance is going to be varies. That is nothing but you can say rheostat. That is nothing but you can say rheostat. Okay, coming to the next one, guys. Which are the following converts mechanical to electrical? Mechanical to finally you are getting electrical energy. Okay, so to get electrical energy, we are rotating the turbine. We are rotating the turbine means we are giving the mechanical energy. We are giving mechanical energy as the input. Mechanical energy as the input. So generator generates the electrical energy. So the answer is option A. Mechanical to electrical, that is the generator. Motor reverse. If you switch on, motor is rotating. Rotating means rotational output. That is nothing but mechanical output. Battery, inside we have the chemical. So outside we are getting electrical. So chemical to electrical is nothing but battery. Rheostat we have already discussed. Okay. Which of the following devices converts chemical energy into electrical energy? Chemical energy into electrical energy. So finally we are getting electrical energy. So hair dryer, no. Electric fan, mechanical. Electric heater, we can say heat energy, and electric cell. So from the electric cell, in the inside of the electric cell, there is a chemical energy is there. Okay. So that chemical energy is converted into electrical energy. Here if we have the cell, inside the cell we have chemicals. Okay, for example, if you can consider lead acid batteries, lead and acid. So these are the chemicals we have, and from that we can get electrical energy. Electrical energy. And this group of cells is nothing but can say battery. Okay, so the inside the battery we have the chemicals, and those chemicals will be converted into electrical energy. Coming to the next one, when will be the circuit when will be the current will flow in the circuit? And don't take Hindi question, it is somewhat of wrong that means translation. Okay, so when will be the current will flow in the circuit? For example, if you can say, if you apply the supply, okay, so here we have one switch, here we have one bulb is there. Okay, one bulb is there. So whenever this switch is going to be closed, whenever the switch is going to be closed, then there is a connection, there is a direct contact, then there is a direct contact like this. Okay, then there is a current will be flow, then bulb glows. Bulb glows. Okay, so whenever the switch is closed, then current is flowing. Whenever the switch is closed, okay. So whenever the switch is open, for example, if this is switch is going to be open, what is happening? Then there is no current is flowing. No current flowing. For example, if the circuit is like this, if the circuit is like this, if the switch is open, not closed, then the current is zero. So bulb may not close. Bulb may not close. So whenever the switch is closed, then current will be flowing, then bulb will be closed. That means in electrical terminology, switch close means switch on. Okay, remember this one, it is enough. Switch open. Switch open. Open means switch on. Okay, this is the terminology used in electrical. So current, when the current is flowing, switch on means current is flowing. Switch off means current may not flow. Okay, so here circuit is switch is closed. Coming to the next one, guys. Ideal voltmeter would have dash internal resistance. What is the purpose of the voltmeter? We have already discussed in the previous questions. Voltmeter used to measure voltage. To measure voltage. Okay, it is always connected in parallel. Always connected in parallel. Okay, and coming to its internal resistance is infinite, very high. Infinite internal resistance. Okay, so the ideal voltmeter having infinite internal resistance. And coming to the same values for in case of current, if you can consider for current, that is nothing but ammeter. Ammeter. Okay, it is always connected in series. Always connected in series. And its internal resistance is 0. And its internal resistance is nothing but 0. Okay, so voltmeter they are asking, that is infinite. Coming to the next one, guys. Units of electric field intensity. Electric field intensity. I have already given the electric field intensity formula. It has the two formulas. One is force on unit positive charge or voltage by distance. So from this force, Newton per coulomb or here voltage, volt distance meter, volt per meter. Okay. So volt per meter given. So we can use the answer as option B. We can use the answer as option B. Coming to the next one, guys. The electric field inside a hollow conductor is dash. Inside a hollow conductor is dash. Here the electric field is always forms like a surface of the conductor generally. So inside we don't have anything in the hollow. So the inside is nothing but 0. So the answer is option B. Inside the hollow conductor the electric field is nothing but 0. The units of current density, very important one. The units of current density. Current density is denoted with the letter J. J is equal to current by unit area. Current by unit area. Current units are amperes and area units are meter square. So ampere per meter square. So ampere per meter square means so the answer is option C. Ampere per meter square. These formulas are very important. All of you make a short notes with all the formulas. It may be very useful for your examination. Coming to the next one, guys. The units of conductivity. I have already given conductivity is denoted with the letter sigma. Sigma is equal to reciprocal of the resistivity. Resistivity is the property which opposes the flow of current. Conductivity is the property which can allow the flow of the current. Okay, resistivity rho. We know the units of resistivity, that is the ohm meter. Now 1 by ohm is nothing but mho per meter. Okay, so we can say mho per meter, and mho is also considered as Siemens. So Siemens per meter. Siemens per meter. Okay. So that is the Siemens per meter or mho per meter. They have given mho per meter. So the answer is option D. So the answer is option D. All of you clear? Coming to the next one, guys. The filament of electric bulb made up of dash. The filament of electric bulb is made up of dash. Here generally the filament material must be having high melting point. High melting point. If it is melt, then there is no flow of the current. There is an open circuit. There is no flow of the current. We cannot get the light. So it may not melt. Okay. So high melting point is our requirement. So in the following, which is having high melting point, generally we are using tungsten. Why? Because tungsten having high melting point, nearly 3400 degrees centigrade. So that's why tungsten is used. That's why tungsten is used. Coming to the next one, guys. Which of the following materials have not used as a fuse material? As not used as the fuse material. So just now I have given the fuse material. Fuse material and filament both are different, guys. Here fuse material must be having low melting point. Must be having low melting point. Okay. Here filament high melting point. Filament and fuse is different. Where we are using fuse, for example, if you have one motor or our loads are there, before connecting the motor or any loads, not only motor, any type of the loads, lights, fans, and there is a main supply case. So in any case, the current is before going to the supply, we are going to connect one fuse. Okay, what is the purpose of the fuse? Whenever there is any fault is there, then in this case of fault, there is a very high amount of the current is flowing through the motor, then motor is going to be damaged. If you are going to use the fuse, what is happening? Whenever there is a high amount of the current is flowing through the fuse material, that heat generated in the fuse is going to be increases. As I increases, heat increases. So due to the higher heat, the fuse is going to be melt. The fuse is going to be melt. Whenever the fuse is going to be melt, then it will open the circuit. Then it will be open the circuit like this. Okay, now fuse is gone. Now the circuit is like this. So then there is no flow of the current through the motor. Okay, so then motor is, whenever there is no current flow, motor is going to be safe now. Now motor is safe. So to protect the device, fuse is used to protect the device. Protect the device from high currents. Okay, so it must be melt. Whenever there is a high amount of the heat, it must be melt. So if it is want to melt, it must having the low melting point. Okay, so fuse must having the low melting point. Here silver, copper, these are having the less melting points. Okay, nearly this copper is nothing but like 1,000, and it is like 900, like that we have. Okay, tin coated copper maybe some less than that of the 1,000. Okay, so but coming to the carbon is having very high melting point. That's why we may not use the carbon. As a fuses. We can use silver, tin coated copper, and these also 600 to 700 like that. So it also that means carbon is high melting point, nearly 3,600 degrees centigrade is the melting point of the carbon. Okay, and operating temperature is also 2,000 degrees centigrade. So very high heat. It can bear very high amount of the heat without melting. So that's why we may not use the carbon. And coming to the next one, fuse operates due to dash effect of electric current. Just now I have given fuse operate on heat energy, I square R into T. Whenever the current is very high, then heat will be high. Then fuse melts. Then no current flows through equipment. Okay, so then equipment will be safe. Okay, so whenever fault is there, fault or short circuit. Okay, short circuit is something what you can say fault. So in this case, the equipment may be safe. It is based on the heating effect of the electric current. You can also say that it is a Joule's law of heating. Okay, students, variable resistance. In the previous session also have given. What is this variable resistance? Variable resistance is nothing but you can say rheostat. It is generally denoted as like this. It is nothing but a long coil. How to take the resistive coil. In this one sliding contact is there. So if you move this sliding contact, then resistance also changes. Okay, so by varying the sliding contact, you can vary the resistance. This variable resistance is nothing but rheostat. Okay, coming to the next one, guys. 1 horsepower is equal to dash watts. 1 horsepower is equal to dash watts. Horsepower is a unit of mechanical power. HP is nothing but horsepower. That is nothing but unit of mechanical power. Okay, that equivalent to electrical power, 1 horsepower is equal to 746 watts or 735.5. 735.5 watts. In old days, they are using this one. Nowadays, we are using this one. Okay. So if they have given 746, go for 746. If the 746 is not there, go for 735.5. Okay. Coming to the next one, guys. 1 kilowatt hour is equal to dash joules. 1 kilowatt hour is equal to dash joules. 3.6 into 10 power 5, 3.6 into 10 power 6, 36 into 10 power 8, 36 into 10 power 6. Okay, so 1 kilowatt hour. We know very well kilowatt hour is a unit of electrical energy. Kilowatt hour is unit of electrical energy. Okay, generally the practical unit, it is the practical unit. Practical 1 unit is equal to 1 kilowatt hour. So 1 kilowatt of the power we have utilized in 1 hour. 1 hour we have continuously utilized 1 kilowatt of the power, then it is a 1 kilowatt hour. Okay, and we know mechanical energy joules. So the relation between this electrical energy to mechanical energy. So that simple is nothing but we have to remember as 1 kilowatt hour is equal to 3.6 into 10 power 6 megajoules. Sorry, 3.6 megajoules. Just remember as 3.6 megajoules. Okay, it is the easiest way to remember. So mega means 10 power 6 na. So 3.6 into 10 power 6 joules. So the answer is option B. For example, if you have not remembered this one, then how to get the answer? Just expand 1 kilowatt hour. You can expand as 1 kilowatt is equal to 1000 watts. 1 hour is equal to 3600 seconds. So 1 watt second is nothing but you can say joule. So now 36 into how many zeros? 1, 2, 3, 4, 5 zeros. 36 into 10 power 5. 1 watt second is equal to joules. So I am going to convert this as 3.6 into 10 power 6. So that is nothing but 3.6 megajoules. So remember this one, 3.6 megajoules. Okay, then you may not forget. If you forget also, no need of worry, you can convert. Clear? And all of you, please try to share the information to all your friends about these free live classes. Safety fuse wire used in domestic electrical appliances is made of metal of low dash. Here, safety fuse wire. Safety fuse wire is works on the principle of heating effect of electrical current. Heating effect. How it is works on the heating effect? Heating effect. Here, for example, here we have one equipment. Let us take one motor is there. Here you have the supply voltage. Before connecting to the supply voltage to the motor, here we are connecting a one fuse wire. So whenever the normal current is flowing, the fuse allows the current and it will flow to the motor, then there is no problem. Whenever there is any fault current, that means high amount of the current is flowing due to any short circuit. Okay, whenever there is a high amount of the current is flowing through the wire, then what is happening? This fuse wire having that same amount of the fault current. Whenever the current is more, heat energy H is equal to I square RT is more. As heat is more, then it is going to be melt. Okay, so it must to be melt. The fuse wire must to be melt. So if the fuse wire is going to be melt like this, the fuse wire is going to be melt like this. Okay, it is going to be melt like this. There is no connection now. Whenever there is no connection, there is no current flow through the motor. There is no current flow through the motor. Whenever there is no current flow through the motor, meter is safe now. Whenever high current or fault current flow through the motor is going to be fail. If the fuse is open, no current is flowing through the motor is safe now. The motor is safe now. Okay, so for the safe of the equipment purpose, we are using a fuse. That's why it is called as a safety fuse wire. Safety fuse wire. So it must have to melt. Whenever there is a high current, it must have the melt. Otherwise, what is happening? If it is not melt, it allows the current through the motor, then motor may be damaged. So it must having the low melting point. It must having the low melting point. If it has a low melting point, then it can melt faster and protect the device. Okay, so it has the low melting point. Coming to the next one, guys. The earth wire of the cable is connected to dash. The earth wire of the cable is connected to dash. If you want to check in any case of in any motor or some any equipments, earth wire to connect the earth wire, one bolt and nut will be given on the surface of the equipment. Okay, that from that bolt we have to connect one earth wire and we have to connect to the earth. What is this purpose? Whenever the equipment outer surface is metallic body, so metallic bodies are nothing but conductors. So whenever there is an internal damage and external damage, okay, then whenever the current wires are touched with this metal body, then some amount of the current is flowing. Or if there is any very near to the conductor also current is flowing, some mutual induction also, there is some current is flowing through the metal. Okay, in that case, whenever any one person is touched the body of the metal, okay, then he get the shock. So to avoid that one, if you connect one wire to the air, here they having zero potential, here they having some high potential to low potential, the current is flowing here. So that means this earth wire provides low resistance path. Low resistance path. Let us take here the potential is very less and its resistance also very less. Nearly we have to maintain 2 to 3 ohms. Okay, or maximum up to 5 ohms. So if the earth resistance is less, we know very well high current is flowing through the low resistance. Whenever the resistance is low opposition, more current is flowing through this one, then there is a very less amount of the current flow through the person, then he may not get any shock. Okay, so we have to connect outer metallic body to appliance. Outer metallic body to appliance. If our frame, the outer surface is a plastic, then no need to connect the earth wire. Why? Because plastic may not give any the shock, may not allow the current. Okay, but plastic having less mechanical strength, so that's why we are always using to get the high mechanical protection. We are using the metal bodies for the protecting cover. So that's why we have to connect the earth wire. Okay. Mica is a dash conductor of electricity. Mica is a dielectric. Dielectric means it not allows the electricity. It may not allows the electricity. So it is a bad conductor of electricity. Bad conductor of electricity. Which of the following scientists give the law of governs the force of attraction or repulsion between the two charged particles? We have already discussed in the starting of the electricity MCQs. That is who given law of attraction, force of attraction or repulsion. That is nothing but Coulomb's. Coulomb's given as that whenever the like charges repel, unlike charges attract. Is the first law. Coulomb's first law. And second law given the magnitude. F is equal to K into product of those two charges by distance between those two square. Okay, so those laws given by the Coulomb's. Coming to the next one. In the following, which are measured by voltmeter, ammeter, and ohmmeter. Voltmeter, voltage. Ammeter, current. Ohmmeter, resistance. Ohms. Ohms means resistance. Voltage, current, and resistance. So the answer is option B. What is the heat generated in a heating element of resistance 900 ohms when a current of 0.3 amps passes through it for 10 seconds is dash. For 10 seconds is dash. What is the heat generated? Heat H is equal to I square R into T na. So I square 0.3 whole square into resistance 900 ohms into time 10 seconds. Okay. So 0.3 whole square 0.09 into 900 into 10. This two zeros, 9, 81, 81 into 10, 810. So that is the 810 joules. Okay, 810 joules.